Alright, today we're going to talk about 3D. And so what if I create a solid by revolving an area around an axis, a horizontal axis or even a vertical axis. And so what I'm talking about is if I have some sort of area and I have, here's my area, and I was going to revolve it around an axis. What would that look like? And so if you're talking about a horizontal axis, like the one I just showed you, you are going to be talking in terms of dx. If we're talking about a vertical axis, so instead, what if I wanted to revolve this shape around the y-axis, then we're talking about dy. So x-axis goes with x, y-axis goes with y. And so if you want to look at it, I wrote down the steps for you to find the disk method. And that's what this is called. We're going to draw the region. And so you need to know, are you talking about in terms of x or y? You want to find your bounds, your a or b. You want to find the radius of each integral. So the radius is going to be what is, if this is going to be rotated, the top of my function to where the axis of revolution is going to be, that's going to be your r in this case. That will be in terms of dx. And then you're going to go ahead and integrate and evaluate. So if you notice, our formulas are all, if you notice, we're creating cross sections of circles. So this is, if I was going to spin this, and I'll show you pictures in class, if I was going to spin this, I'm just creating a bunch of different circles. That's what the pi r squared is from. Alright, so what if I had a region enclosed by the x-axis, the line x equals 3, the curve y equals the square root of x, and it's rotated about the x-axis. So since it's rotating around the x-axis, I know it's going to be in terms of dx. So we're really just talking about quadrant 1. And x equals 3, so we're going to call this right here x equals 3. And so we have a curve that's being rotated around the x-axis. Belle, stop. Wait. I know you like it, buddy. And so we're rotating around the x-axis, so we're talking about dx. No, you can't touch, Elliot. Alright, so if you notice, my bounds are going to go from 0 to 3. We're going to have pi, that's part of it, and so our r squared is going to be, don't touch, this right here. This is my r squared. That's my r. And so all we have to do is what is our function? So we're talking about the square root of x, and we're going to square it. And again, it's going to be in terms of dx. So this becomes pi from 0 to 3 of x dx. And so if I was going to take the antiderivative of that, you're going to get x squared over 2. This whole thing is going to be multiplied by pi. I know, it is up there on the TV. And it's going to be evaluated from 0 to 3. Stop it, dog. Alright, so we have pi. This will be 9 over 2. And so that's the area. So 9 pi over 2. We don't really need to worry about 0 because we're going to subtract. When I plug in, we're going to get 0. So we're going to get 9 pi over 2. Alright, number 2, find the volume of the solid generated by revolving x equals the square root of 1 plus y, with y is equal to 3 and x is equal to 0 about the y-axis. And so And so if I was going to square both sides of this guy, that means this becomes x squared is equal to 1 plus y. And so I get y is equal to x squared minus 1. But we're only talking about the positive side. So, do I write plus 1? No, I wrote minus 1. So we're only talking the positive side, so this guy right here. And so we're going to revolve that, and y equals 3. So 1, 2, 3. There's our upper bound. You'll notice our lower bound is -1. And we're talking about this area right here, and we're revolving it around the y-axis, so we're talking about in terms of dy. I know, that's Mommy's graph. Alright, and so when we talk about r, we're talking about this region right here. So my r is actually going to be the square root of 1 plus y. So we're going from -1 to 3. And we're going to multiply that by pi, because we're talking about circles, cross sections of circles. And so we have the square root of 1 plus y squared times dy. So I'm going to simplify that. So we have pi multiplied by our integral from 1 to 3 of 1 plus y dy. So if I was going to take the antiderivative of this, I'm going to have pi times y minus y squared over 2. Evaluated from -1 to 3. And so when I plug in, I have pi times 3 minus 3 squared is 9, so 9 over 2. Minus... No. Absolutely not. -1 minus -1 squared is going to be 1, so it'll be 1/2. And when you simplify all this, you're going to get... Sorry about this. Sorry and all the chaos that's going on in the background. I have to watch both the dog and my son at the same time. So sorry, guys. And so you're going to get, I believe it's 8 pi. Alright, number 2, finding the volume in the problem. Number 2, using a calculator. And I'm just going to pretend that x and y are the same. And so what I mean by that is I can't really plug in y and have that as my independent variable. So instead I'm just going to go ahead and represent that independent variable by x. So I'm going to go to y equals. And I'm going to do the second square root of 1 plus, in this case, x. Quit. And then I'm going to hit pi, so second pi. And then we're going to do math 9. And then since it's stored in y1, we're going to go variables, y variables. y1, we're going to square it. Comma, area independent variable, comma. Our lower bound, if you remember from the previous problem, was -1. Our upper bound was 3. We go ahead and hit enter. And if you'll notice, if you do 8 pi, you're actually going to get the same answer.